Hello everyone, and welcome back to a new episode of SHENZHEN I. Let's see what the next puzzle is. Why is it pointing us at like this one, Three Kingdoms? Did I review this recently or something? I don't know. Anyway, the next puzzle that we have is a control router, which is important, evidently. I'm pleased to say we've been selected for another SHENZHEN project, a simple data router for smart grids. Mr. Sun was never interested in civic infrastructure before, to my knowledge, so I really wonder what he's planning. I may ask around. My uncle's had dinner with him once or twice. We can do it. These XBus inputs are blocking, so we need to connect all inputs so they can be read at once simultaneously. Okay. Who was the SHENZHEN guy? Like, is he the one doing aquaponics? Yes. So this is clearly some sort of military contractor who's taking advantage of our silly and naive company. Okay, what is this? I can move this, right? Okay. Meter in and meter out are XBus inputs and outputs. Meter out, meter in. Okay. They connect this node to a building's smart grid power meter. Lower in and lower out are XBus inputs and outputs that connect this node to a node with a lower ID number. Higher in and higher out are XBus inputs and outputs that connect this node to a node with a higher ID number. The first value in a data packet is the ID number of the destination and indicates how the packet should be handled. Okay. So if it's less, then send it to the lower thing. Yeah, okay, so we're just gonna route it like that. Otherwise, retransmit to the meter. But all of these are blocking. Interesting. Oh. The local ID number is stored in a secure identity chip that can be read as an XBus input. The second value in a data packet is the length of the rest of this packet. Okay. Huh. Alright, so at a given time unit, we're going to receive one input from one of the, we'll never be receiving inputs from two different places at once. And transmitting the information is instantaneous, so it all happens in that same, what's it called? Same time unit. So it should be interesting to figure out like how to, I don't know. We kind of need to like demultiplex on these guys somehow. Well, we need to like do multiplexing properly somehow, right? We have to, I think, read a value from one of these. Wait, do we ever get anything from meter in? What does that do? What does meter in? Connects it to a smart grid power meter. So okay. So what do we ever get anything on meter in? We do. Alright, I guess the first question is, what is the idea of this node in this particular test? Like in the verification tests, they're saying, hey, 301 should be routed to lower, but I'm just curious, like, move x0 into act. What is our actual number? In this example, it's 596. Okay, fine. So it kind of seems like, well, alright. My first guess is that we actually need at least 6 of these guys, which seems... not 6, 4. Like so, with 3 inputs that all connect to a single output, basically. And then this... well... They can't even really connect directly to the output, exactly. Oh yeah, they can, because they can all use the same wire to write to it even. That's kind of handy. The problem, we can't, like, I think, we can't even do something like this because these inputs are blocking. And if we can only have a single chip sleep X on one of the 2 inputs, right? And if it sleeps on the first one and the packet arrives over the second wire, then, like, tough luck, you're never going to receive that packet. Which is why I think that we absolutely must have 3 controllers over here, 1 for each of these guys. And then I think we need a large chip here for the output because it needs to read this as well. Oh wait, no, that doesn't even help. I was thinking it needs to like read this, and it needs to write to these 3 things, and that's 4. And it also needs to read from one of these guys, and that's 5. And so like this chip would not be large enough, it only has 4 XBus inputs. But this also only has 4 XBus inputs, so that's not exactly helpful. It does add some direct simple I/O, but I'm not sure how we can make use of that. And I think it would also probably be nice for this guy to have 2 registers. One to store how many bytes are left in the packet, how many inputs are left in the packet. Maybe it doesn't need to know that. Exactly. Nah. So, some part of the question is, like, how smart does this device here need to be? Does it need to know the length of the packet that it's transmitting? What if we saved the packet's destination onto a simple I/O wire rather than communicating that over XBus? Would that help at all? Actually, doesn't really seem like it. It would mean we wouldn't need a... We can't use any kind of interesting muxing, right? We can't use the muxers for anything because they only... you can't use them to write as direct simple I/O because they can only write 0 and 100. And you can't use them to write XBus because they always write the same things, and also it can only be like single digits, or it can only be like 1s and 0s. in each digit. So, honestly, it feels like I'm a little cramped for space here. I'm not sure what I'm supposed to do. Okay, so hang on. Maybe the way that we can resolve the problem of this controller needing more XBus ports than it has is to not have it connect to this chip. Instead, it connects to the 3 outputs and to the 3 input chips. Each of these guys, when it reads a packet, compares the destination to the value here and decides where to forward it to, and sends that as a header to the output controller saying, okay, wake up, here's a value, and well, here comes a packet, here's where you should send it, and here's how long it is, and then here's the bytes. That seems like an okay protocol for these guys to talk to each other, which would enable this guy to not need to connect to this. Okay, and so the wiring for that seems relatively simple, I think. Yeah, we do want these chips, the ones with 3x, but we don't have any, simple I/O to do. So, I mean, I actually can't do that with a bridge, can I? But it's fine because I can do this. I could maybe connect to this end instead, but I don't see why. Okay, so let's write the code for this guy first, right? The first thing he gets is the destination, which is good. If I got the length first, it would be a little awkward. So what we're gonna do, we're gonna sleep x on x0, and then can we use a test compare, or do we need to do... Okay. Let's move 0, well, we'll indicate these 3 destinations as 1, 0, and -1. So let's move a 0 into ACK here, speculatively saying, let's just assume it's destined for us, and then we'll use a test compare to overwrite those values. So test compare... Oh no! I need to actually... Oh no, that's fine. That's fine. The destination is still going to be an ACK after this compare, and then we can forward it along. In fact, we could forward it along before we did the compare, but I think it would be better not to. Wait. Oh, we were gonna write this to someplace. We were gonna write it as like a simple I/O, weren't we? And we don't have any simple I/O ports available. If there were a single chip with 3 XBus and 1 simple I/O, that would be handy, I think. But we don't have that. Muxer, I guess? Not really. I mean, we could write either 110 or 100 to this thing, and have its simple I/O ports all feed into this guy's 2, and then we could test, is it low, is it mid? Well, if neither, it must be high, so like we could do that. I'm not sure that's a great idea. What else would we do? We could write it to another chip. You know, another one of these guys. Not sure exactly how that would work out. I really don't like that I'm having to use 3 of these guys. I think that's like mandatory. I can't see any way around that. None of this stuff seems that useful. Does it? What about a read-write RAM? What if I wrote the entire thing into a RAM chip, including the destination, maybe? I'm not sure how that would help compared to just compared to just sending it directly over XBus to this. It's not obvious to me how that's better. And also, I don't think we have enough ports on these guys to mess with that. I guess if we disconnected them from this, we would, but then like this guy would need to connect to that, and I think we determined that he can't afford to. This puzzle makes me laugh because this is like the simplest possible representation of the kind of stuff that I think I'm supposed to be doing for work eventually, once I learn enough things, is like doing routers. This is the simplest kind of routing you could possibly imagine, but with like the worst tools that exist. So like, it's not that I feel bad that I can't figure this out yet, but it does make me feel a little silly. I'm still not sure exactly where we're storing the information about how to route the packet. That's the interesting. That's the thing that I'm currently struggling with, I think. Because like, obviously I could finish writing this test compare and I could write a number to the output somewhere. I'm just not sure what to do with it. Maybe writing it into a muxer is the thing to do? Doesn't feel very good. And also it makes the wiring pretty confusing. Is there some way... Wait a minute. I think I can just write it to this guy, right, over the XBus wire, and have him put it into his DAT or something. Maybe that's fine. Right, because we're using his registers, DAT for where it's going, AC for the length of the packet remaining. Now, the thing I never quite resolved is can this guy afford to not even know the length of the packet he's sending? Just sleep until he gets an input, and he's like, oh, an input, let me send that. And it's hard for me to see exactly how to do that, because there needs to be some kind of input we can send that says switch where you're writing to, that we do when we get a packet, right? And if we send that in band on the XBus line, like, I don't think it's possible, because any number from 999 to minus 999 could show up as part of a legitimate packet. And then we would need to forward it rather than do something silly. So in order to do that, we have to either know the length of the packet we're sending inside of this guy, or have the output communicated in some kind of, the output location communicated in some kind of out-of-band fashion. And so that's what I was talking about with this guy, is like, could we do this somehow? Not even sure what the wiring would look like, but we would need each of these guys to communicate to this somehow. Like, yeah, I don't see how this is gonna work. I guess it is actually the way we have to do it. And then, like, also have them all talk to this, which, like, already is getting to be impossible. And then we have to wire this up into this guy twice and still get this out to here. Like, I just don't see that working. So I think we have to send it in band, which means that we have to track the length. But okay, it was good to have thought about that a little harder and see just how difficult it is to do. Wait. No, yeah, okay, that's right. So this guy, let's wire him up, I guess. Wire there, wire there. Wire here. And then we'll just have these guys uniformly connect with their X3. Like so. This is starting to look a lot, actually, like that one that I almost gave up and rage quit the game for. Right? Like, I think the vape pens one, I had inputs set up like this, and it was just awful. Because or outputs were like this, I think. Because I had just, like, not thought about the right architecture in terms of how to actually control the output. But I feel like here, I have to do it this way. And at least the wiring looks a little nicer than it did. This is complicated, but regular. What are we mad about here? Oh, expect yet. I just haven't finished typing all this out. So, like, what would this guy's program be like? It would be move, well, sleep for x1, and then move x1 into dat. This is the thing telling us where to write to. And we're then going to read the length, I guess. It's a little bit, I'm not sure exactly, because it would be nice if these two packets were reordered from the point of view of this guy, right? I think. It's just a little bit like, we need to read the first thing, which is where it's going to go. And then ideally, I would want to read the length and put that into ACK. Oh, wait, the length... The length is how many bytes are left, yes? Uh-huh. So... So the thing is, DAT is not actually going to store the first packet. It's going to store a number, 0, 1, or 2, indicating which output we're writing to. And then, I guess, we'll want to receive the first packet and send it to the right place. And then receive the length and send it to the right place. And store it in ACK. And then go into a loop where we start reading things. So it seems like there's going to be some duplication here in how we actually output, which makes me sad. What if we, like, had this guy who's responsible for understanding the protocol here not be responsible for actually writing the packets out, but instead he sends them to one last subcontroller whose job is to actually write it out, and we send him a simpler protocol, which is just any number of 2-byte packets. Each one of them says where to write it to, and what to write. Then in here, we can sort of deal with the... We can spend fewer instructions on actually writing, because we're gonna have to, like... We're gonna have to choose, since we can't make the stuff about reading in the first 2 bytes of the packet, we can't make that be part of the main loop because it has to deal with reading the length and so on. We're gonna have like 3 times to decide how to write a packet. We're gonna have to write that code 3 times. And it's gonna be like really long, right? So we're gonna have to test ACK, or DAT, I mean, to see which thing we should be forwarding to, compare it against 0, compare it against 1. So it's going to be like 5 instructions just to write a single byte. And we're going to have to do that at least 3 times, and we can't fit that on here, right? So it seems like this guy can't be in charge of writing all these. He has to take this protocol, which is like maybe not so easy to consume, and convert it into a protocol that can be followed more regularly, just like, here's a byte, send it somewhere. So maybe that's the thing to do. I worry that this is overcomplicating things again, as I have done in the past, but I'm also not sure how to do without that sort of separation. So, if he's not the one writing to the output, let's not put him in the prime real estate area. It also means, interestingly, that he could read from this if he wanted, instead of these guys all doing it. I think. Right? Because now he doesn't need so many XBus ports anymore? I think that's true. Assuming we can fit the code in for doing that in here, which I think we could. Yeah. Okay, so it means we simplify all of this. And instead, oh, heck, let's move this even higher, right? Here we go. Like so. Move back 0 to DAT. Well, yeah. I think I want to move it to back first, actually. The idea is we'll read our read x1, which is the first byte of the packet, which is destination number, into ACK. And then we'll also move a 0 into DAT. So this is, I don't know why this dang M key, something I do wrong. Anyway, speculatively, like we talked about, move a 0 in there, and then we'll do like a test compare that lets us override that to be some different number. So test compare ACK and x0. If ACK is greater than x0, then we need to send it to higher out, which we're calling 1. Move 1 into DAT. And if it's less, we need to move -1 into DAT. And if it's equal, we leave DAT alone. That's the idea. Actually, maybe instead of sending 2-byte packets, what we should do is save that value to a simple I/O port, right? I'm feeling a little cramped for horizontal space. Maybe it is a good idea to trim all these wires and move everything. Oops. Move everything left a bit. Like so. There. Maybe I needed to. Maybe the point. Well, I don't know. I guess we can connect the P1 chip. I think that ought to be okay. Yeah, run the P1 like this. I don't know exactly. Something like that. Probably put this in here. Here? Oh, that's the X pin. There we go. Oh, no, because we can't do that unless we use a larger chip, which I don't think we need to do. Because this guy then only has 2 X bus ports, but he needs 4, right? 3 for this and 1 for talking to this. So that's no good. All right. Well, maybe we can afford the duplication. We're kind of talking like doing that, that, and that, basically, then. So his whole thing is basically sleep X on X0, move X0 into ACK, test equal ACK of 0, in which case move X0 to X2, otherwise test equal ACK of -1, in which case move X0 into X1, otherwise test equal ACK of 1, in which case move X0 to X3. So this is like how I imagine this guy working. And then we just have to make sure that we can actually afford to send that protocol to this guy. So fine, we've put into DAT the destination for where this stuff is going. So we move DAT over X2. which of these? Yeah, okay. So X1 is what contains where we're actually sending the thing. That packet has not yet been touched, which is good. And we move X1 to X2. And now we get the length, so we move X1 into ACK, move ACK onto X2. No, also DAT. Move DAT to X2. Oh no, I'm gonna run out of room. Right? Oh god. So what exactly are we going to have to do here? Maybe we can fit it in these last 3 precious lines. God, if I had 4 lines, I'd be okay. Well, so that's telling me that I might need to actually upgrade this guy to a larger chip so that they can also communicate over simple I/O. Although I'm not sure how I'm going to wire it up, but it seems like it would be useful. Because then I won't have to keep writing the destination on every packet. Just write it once and then forget it. But okay, let's see if we can somehow squeeze in the existing protocol in here. So what exactly do we have to do in the loop here? What can we maybe... okay, so we need to I think this has to be the top of our loop, the line we're about to write. It has to be we have to start by seeing if accumulator is 0. And then if so, well, and then if so, we jump back to the top, right? We stop, we go back to sleeping. So great, but that's 2 instructions, and then it's 2 more to actually forward on the packet we get, right? So I don't see how we can do that in 3, and so I'm trying to look through here to see if there's any place where we could save 1 instruction. We have to start with sleeping. Yeah, I agree. Move X1 into ACK. I think we have to do that because we have to save the packet number, or the destination ID number. Move 0 into DAT. We need some way to get a 0 there because we're putting a number that's either 0, 1, or -1. So that means, I think, that these 4 instructions are the cheapest way we could fit everything in here. We need a default case, we need a test, and we need the 2 other cases. Now we're moving DAT over X2 and moving X1 over X2. Oh, is that wrong, by the way? It is. Because we need to... First, we need to actually... oh yeah, this is... It's not costing us more instructions, but this was supposed to be ACK, the value we saved. And then we move x1, the length, into ACK. Move dat to x2. Move ACK to x2, writing out the length and where to put it. And then we're stuck, right? So, if we could somehow combine these steps, maybe? Wait, yeah. Like, obviously, these, like, move a thing to x2, they're, like, duplicated, right? But I don't see how we can fix that. If we had functions, we could just put it in a function, but we don't. Okay. So I'm starting to think that this simple protocol that we invented is just a little bit too expensive for this guy to handle. Imagine how much worse it would be if he had to do this every time he needed to send a packet instead of just 2 bytes worth of stuff, huh? But okay, we need it to be even worse, so rewire everything. Well, I actually don't know how much we have to rewire. So here's, like, I think the idea. Ugh, no! Port connected to self? What part? What part? What? Which one of these guys writes to itself? I don't see it. Huh. Oh, this guy, of course, yeah. Okay. So we need to, like, make... We need to make that port readable. Because they need to, we decided, talk over simple I/O as well. But if they do, how can we even connect this up? Can we do we simplify by moving this down, or do we make it even more complicated? I'm not sure. Well, let's route Let's route x1 over to here. Ah, yeah, we can make this work. Like that, right? Now, let's see. They're talking over... Actually, we don't even need this bridge. We can do that. Yeah, we'll just change all these x3s, or x2s to x3s. We'll probably change it even more. Because instead of writing to dat, we're going to be writing to p1. And we can't use 1 minus 1. We have to use, like, 0, 1, and 2 or something. So let's actually make the neutral be a 1, the plus be a 2, and the minus be a 0. But instead of writing it to dat, we'll write it to P1, P1. Now we can erase these lines and just have this guy be looking at P1 Oh, and he doesn't have to move it into ACK, huh? P1. But we said the neutral is a 1. This is a 0. And this is a 2. P1. Okay. So now we freed up some space here. This is getting to be a mess, isn't it? These guys are real simple though, right? They literally are just like sleep until you get a thing and then write it. That's their entire code. We put all the smarts into this guy. Maybe it would have been nice to figure out a way to not do that. In fact, maybe we could have done that by having these guys connect to this thing like we were talking about earlier, and then maybe this could be smaller. I don't know. I think we could maybe arrange it that way. I forgot to think about that. That maybe we could have these guys send a single packet saying, hey, here's where the data's going, by way of reading this stuff. I don't know. But okay, so we moved x1. What were we up to? We figured out where it's going. Then we wrote act x3, which was our destination packet. Now we're moving x1 into act, which is our length, and act to x3, so we've written the length. And now we could test whether the length is 0 at the beginning of the packet, or we could do it at the end, after writing a thing. I think it would be more correct to do it now, because we haven't been given a spec, and maybe it's legal to send 0 length packets, but I don't think there will be any 0 length packets, so we can forget it. We'll just not handle that case, and if it turns out that case comes up, it's easy to fix. So we will now just say move, let's call this copy, move x1 into x3, test, sub 1, test equal act 0, and if it's not 0, then, is that right? Yeah, that act is representing the number of bytes left to copy. So if it's 0, we're done. If it's not 0, we'll jump to copy. Okay? And so these guys are just as easy as you can imagine. Move x0 to x3. That's the whole program. Okay. Yeah, it definitely seems like these guys have room to do some number crunching on the value from here. And then make this guy not need to do its simple input tricks. But okay, whatever. Let's not worry about that. So we do, everybody just sleeps for the first cycle, great. Now, no, 696 apparently is our ID number. Okay, so we step. This guy woke up, and so he's read 596, which is less than us. Oh no, that's a 5? Really? Alright, looked like a 6 to me. So we send that. This guy wakes up and he reads first the actual packet and puts it in ACK. Then he moves he moves 1 onto the communication line and compares ACK with our identity number. They're equal, so he doesn't do anything. He leaves the 1 alone. Moves ACK to x3. Says, here you go. Here's a byte to write. This guy checks where the byte should go. Is it equal to 1? Yes. Therefore, we take it and we move it to x2. Whoops, sent it to the wrong place. Yeah, I guess I thought that, like, I don't know, whatever. Let's be a little, so 1 means it should go to higher out, so that should be, wait, what? 1 doesn't mean it should go to higher out. 1 means it should go to the meter, which is x3. 0 means it should go to the lower out, which is x2. No. Lower out was x1. And 2 means it should go to the higher out, which is x2. Alright, so that was fine. We just needed to do that one change. He says, is this? Oh yeah, right, he sends it to meter out. Great. And meanwhile, these guys have been talking a little. We've read the length in to ACK, which is 4. And we're now going to send that to this guy. Here's your 4. He tests where to send it, determines to send it here. There it goes. Now we're copying. We move x1 to x2, so here's the 81. This guy has to do a little work to decide where to go. Okay. Alright, this copying is going along alright. Let's make sure this is going okay. We sub 1, is it 0? No, therefore go back to copying. And now we're back to sleep. Everyone, time can advance. Great. Look at that. It's amazing. We wrote to the wrong place. We wrote to x3 twice here. Okay. So when it's supposed to go to higher out, we... Ah! What is that? Go away. Instead of going to higher out, which is x2, we wrote to x3 here. So this certainly could be simplified, but not by a lot, I feel like. I feel like the best we could really do is replace this with a smaller chip and write more code in these guys and less code here. Which would cost us more power, but less parts. Wow! Wow! What did I do wrong? Look at all the money we spent on parts. Like, nobody spent this much on parts. What am I missing? I feel like I needed almost all of this. Like, guaranteed 100%. Like, these guys were doing it for 1, 2, 3, 4. So times 1.5 and 5, 6, 7. These guys were doing it for like $10. How do you do that? I mean, I'm sure this is another case of, like, something where I just, like, there's some assumption I made that's totally wrong. What is it, though? I feel like we really do need 3 different chips for reading these guys, and that's 9. But maybe we don't need any of this? Maybe each of these guys can somehow manage to do all the work necessary to decide which of these outputs to write to? But that costs them 4 ports, and then they can't read from this. Like, I have no idea. I look forward to seeing how somebody else solved this problem. Because my solution seems not nearly as bad as it apparently actually is. I'm still reasonably happy with this solution, except for the fact that I know everyone else was smarter than me. I don't know. Well, let's get our rewards. What do these guys have to say? This is just the tip of the iceberg. Mr. Soon is apparently pulling in a lot of resources and groups to create various subsystems for something. Nobody knows what it is, other than it's going to be very big and potentially very lucrative for the firms involved. We're on a path to further our good relationship with the group and eventually become trusted partners, so let's continue to do our best work here. We seem very trusting. Okay, we've got 4 more things to do in the future sometime. Not this episode, though. We are done. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.